Ever wonder how gold gets concentrated in the Earth's crust? It's not magic, it's hydrothermal alteration. Deep underground, superheated, mineral-rich water circulates through cracks, dissolving and redepositing minerals as it goes. When these hot fluids interact with rock, they change its color, texture, and mineral makeup, creating visible alteration zones. Gold often travels in these fluids, precipitating out as the fluids cool or react with new rocks, forming veins or spreading through altered rock. For prospectors, these alteration zones are giant signposts, much easier to spot than the gold itself. A gold vein might be inches wide, but the surrounding alteration can stretch for hundreds of feet, creating a broad target. By learning to recognize the colors, textures, and minerals of altered zones, you can zero in on the most promising areas. In this guide, we'll break down the key ingredients for alteration, show you how to spot the main zones, and teach you to follow these clues like a geological detective. Let's dive into the story written in the rocks, and learn how to read the signs that lead to gold. Hydrothermal alteration starts with heat, usually from a magma chamber deep underground. This heat supercharges water, turning it into a powerful mineral-dissolving fluid. The fluid, often groundwater or water from the magma itself, picks up metals like gold and carries them through the crust. But it needs pathways, cracks, faults, and permeable rocks to move and interact with the host rock. These structures act as the Earth's plumbing, guiding the fluids and controlling where alteration and gold deposition happen. The closer you are to the heat and main pathways, the more intense the alteration. Understanding the interplay of heat, fluid, and structure is the first step to finding gold. Follow the patterns. Heat drives the system, fluids carry the gold, and pathways show you where to look. Master these basics and you're ready to decode the clues left by ancient hydrothermal systems. The propylitic zone is the outermost, coolest, and most widespread alteration halo. Here, rocks turn pale green or grayish-green thanks to minerals like chlorite and epidote. You'll often spot tiny flecks of pyrite, fool's gold, scattered throughout. While this zone rarely contains much gold, it's a clear sign you're near a bigger system. Think of it as the suburbs around a city, vast, but pointing you toward the action. If you find green-tinged, slightly softer rocks with pyrite, you're in the propylitic zone. Your goal? Move inward, following the gradient of increasing alteration. The propylitic zone is your first big clue. Follow it, and you're on the trail to richer targets. It's not the gold itself, but it's the map that leads you closer. Move inward, and you'll hit the Argillic zone, where hot acidic fluids turn feldspars into soft white clays like kaolinite. The rock here is chalky, bleached, and often crumbly, easy to dig with a knife. This zone signals you're getting closer to the main fluid pathways and potential gold. Sometimes you'll find an even more intense advanced Argillic zone marked by vuggy silica, alunite, and pyrophyllite. These rocks are often bright white, yellow, or red with a spongy texture. Advanced Argillic alteration is a top indicator for high sulfidation gold deposits. If you see these signs, you're near the system's core. Prime ground for gold exploration. The closer you get, the hotter and more aggressive the alteration becomes. At the system's heart, you'll find silicification, where rocks are flooded with silica, forming hard quartz veins or massive jasperoid. These zones are prime gold targets as gold often precipitates with quartz when fluids cool. Look for quartz veins with bands, vugs, or sulfide minerals like pyrite, classic signs of gold potential. At the surface, weathering creates iron caps or gossans, colorful stains of red, orange, and yellow from oxidized pyrite. Gossans are visible beacons marking the spot where sulfide-rich zones lie below. Gold, being resistant to weathering, can be concentrated in these iron caps, a bonus for prospectors. A large, colorful gossan is a billboard dig here, and you might find the primary gold zone beneath. Silicification and iron caps are the bullseye of the alteration target. The host rock, the canvas for alteration, shapes what you see in the field. In volcanic rocks like andesite, propylitic alteration turns them pale green with chlorite and epidote. In limestone, fluids may create marble, jasperoid, or even dissolve the rock to form mineral-rich skarns. Ultramafic rocks react to form talc, magnesite, and bright green fuchsite, key indicators for gold in these settings. Granite hosts show subtle changes, feldspars turn to white clay, and biotite alters to green chlorite. Stockworks of quartz veinlets in granite signal intense fluid flow. Always identify your host rock first. Alteration minerals mean different things in different rocks. Misreading the host can lead you astray. Get it right, and you'll interpret the clues correctly. The story of gold is written differently on every geological canvas. Structure is king. Faults, fractures, and shear zones control where fluids flow and where gold is deposited. These features act as superhighways, focusing alteration and mineralization along their paths. Look for linear features in the landscape, straight valleys, aligned ridges, or abrupt rock changes. Fault intersections are especially promising, creating zones of intense fracturing and fluid pooling, prime spots for rich ore bodies. Bends or jogs in faults can form open spaces perfect for quartz and gold to precipitate. As a prospector, walk these structural corridors and focus on where alteration is strongest. Mapping fault orientations helps pinpoint high-potential targets. Structure dictates fluid flow, and fluid flow dictates where you'll find gold. Follow the structure, and you follow the gold. Now, let's put it all together in the field. Start by mapping the boundaries between alteration zones, green propylitic, white argillic, hard silicified ridges, and colorful gossans. Use your rock hammer to break open samples and a hand lens to spot key minerals. Collect and label samples from each zone to see the progression toward the system's core. Look for color anomalies, feel for soft or hard textures, and even listen for the ring of silicified rock. Every observation is a clue. Connect the dots to reveal the hidden system. Reading alteration zones is like decoding a treasure map, where the land itself is the guide. The more you practice, the better you'll get at spotting the subtle signs. With knowledge and keen observation, you can turn barren ground into a gold discovery. The alteration halo is your beacon. Follow it, and you just might strike gold.